So question 14 says follow the following data represents the number of a major hurricane strikes in a particular country each decade from 1921 to 2000. So we have 1921 to 1930, that's a decade. They're going to let X be 1 for the first decade, if you will. And there was 3 hurricane strikes in that country. In 1931 to 1940, we're going to say that's the second decade that we're talking about. That's going to be 6 hurricane strikes. So then we're seeing 8, and then we're seeing 6, 4, 2, and then we're seeing 3 and 3. So it kind of looks like it's increasing, and then it's decreasing, and then it looks like it's increasing. So it sounds like there's 2 turning points. So that could be considered like a cubic function. So if I'm looking at the data, I should see increasing to start with, decreasing, and then increasing again. This graph here looks kind of like what we're talking about just by looking at the data. So I do want to pause the video here in a second and go ahead and just put the data into the calculator using the stat button. So it's stat and then go over here to edit. We can kind of go up and clear, come down, go over, go up and clear and come down. So the X's are going to be the 1 through 8, and then the Y's are going to be the hurricane strikes. So I'll pause for a second. So now I've got the data entered into the calculator. It looks like I've got it okay there. So again, if I want to do a scatter plot, we have to go back to stat plot. Notice that I've turned all this stuff off again. So if I enter, got to turn that back on. Then we can quit this because everything else looks correct. Now remember to graph it, if with the zoom button and number 9, it'll create the scatter plot. And that's kind of mirroring what we're looking at over here. Again, if we wanted to, we could change our window to be like their window. So if we wanted to, we could use their settings to see it more accurately. But if you look at our window, it's basically saying 0 to 9, that's kind of what they've got going on here, basically 0 to 9, if you want to clean that up. And then the Y's, if you really want to go back down to 0 again, the Y max looks like they went up to 12. So if I graph again, notice that probably makes it look a little more like theirs in that sense. The scales are a little bit more close. So again, this is going to be considered a cubic function because it does have 2 turns. So if it's got 2 turns, it's got to be at least 1 higher. So it's got to be at least a cubic function. So it's definitely not linear in that sense, it looks like it is making some type of pattern. So the cubic function, so I'm kind of wondering if this is the actual one we get in the calculator. So if we hit the second calculate button, nope, hit the stat, go to calculate. Number 6 is a cubic regression. Do we get those same coefficients? So notice that actually generates the same function. So we've got that into the calculator already. So anyway, so the function is, let's put that into the calculator. Y equals 0.159 x cubed minus 2.32 x squared plus 9.33 minus n. Okay. So that's in the calculator. So if the function is described by this equation, use the graphing utility to verify the cubic function of best fit. Use this function to predict the major hurricanes between 1961 and 1970. So we did kind of verify by going to that stat and going to calculate. So that kind of verified it there. So we did do that. So that cubic regression is the one we wanted. Which one was that again? So stat, calculate, that was number 6. Okay. So now what it's asking is, in 1961 and 1970, use this formula to predict the number of hurricanes. Well, 61 to 70 was where we were saying the 5th decade, and the actual was 4. Let's see what the predicting does. So if I go to the table and go to 5, this says 4.31, so that's rounds to about 4 hurricanes as well. So notice how it said around to the nearest integer. So whole values, no decimals. So 4.3 would round down to 4, not round up to 5. So that does kind of mirror what the actual was. So if we want to draw the scatter plot, we're probably going to, if we draw the regression line now, it probably is going to be this one. So the graph, notice how it kind of mirrors that. Now my scale may be a little bit different, but notice how it's got to be a smooth, continuous curve. This is just connecting the dots. That's not a continuous smooth curve. And this one's not going through the data very well at all. That's more quadratic. That's more linear. But notice how cubic actually traces the flow of the data much better. So question D, concern has risen about the increase in the number of intensity of hurricanes, but some scientists believe this is just a natural fluctuation that could last another decade or two. Use your model to predict the number of major hurricanes that will strike in 2001 and 2010. So 2001 and 2010, notice that 1991 to 2000, we were using 8. So 2001 to 2010, we'd be using the 9th decade. So if I go to my table, the 9th decade, we're seeing 7.7, so that's going to round up to 8. Does your result appear with what the scientists believe? So notice how we are expecting another fluctuation at this point, so it should be going up. So we are kind of picking up on that as a natural fluctuation. So from 2001 to 2005, 4 hurricanes struck. Well, that's half of this. So that sounds right. Does this support or contradict your prediction? Well, like I said, half of 8 is 4, so that does support it. So that's where we have to, as people who are not scientists, kind of try to figure this all out. You know, there is this concept of climate change that out there that's also affecting our weather. So now we're getting like a double whammy because of where we are. The intensity of hurricanes are increasing, but because of climate change, they're increasing intensity by much, much more and more common. So that's the thing we have to watch out for is, yes, we have this natural fluctuation, but this intensity is setting records. So we have to watch out about climate change as well.